Hi, back again. We're doing problem number 15, okay? Now, in this case, in problem 15, and again in problem 17, 15, 16, and 17 actually, we're solving for something other than the future value or the present value, as I mentioned here. Whenever you're doing something that does not involve an annuity, I usually recommend you use table 1. Theoretically, you could use table 2. But I like to keep things easy, so the table 1 formula, as you'll recall, is future value equals present value times FVIF, which is some value from table number 1, or table A, okay? Why did I choose that table? Number 1, it's not an annuity, okay? It's a one-shot deal. Madani is investing this amount of money once and once only, so it's got to be either table 1 or 2. We throw out 3 or 4. Secondly, we say which way we're traveling on the timeline. Well, we're traveling from the $87.60 he invests today forward to $60,000 that he wants to have. So I'm going to stick with table number 1. Okay? So if you replace all of the factors here, the future value that Madani wants is $60,000, and we know that's going to be equal to the $87.60 that he's investing now times some FVIF. Let me make that all caps to be consistent, FVIF. Okay? So when you solve a problem like this, you do it in 2 steps. You solve for the unknown first of all, the FVIF. Number 2, we're going to have to say, based on that FVIF, I've got to either know the time and solve for the rate, or I need to know the rate and solve for the time, okay? In this case, we know what the time is. We know it's going to be 17 years from now. Okay, very good. Let's do step 1 first. So we divide both sides by 8760. So that's going to become $60,000 divided by 8760, and that's going to be equal to the FVIF, and we'll use that to help us out. Okay, so the FVIF, therefore, is going to have to be equal to $60,000 divided by 8760, and obviously the number is, I'm going to give us a lot of decimal places here, 6.8493. Okay, very good. Now that we have that number, we know that that number lives somewhere within table number 1, okay? So, since we are solving for the interest rate, okay, we have to know the amount of time involved, and that amount of time is 17 years, okay? Right there, 17 years from now. So what we do is we come over here to table number 1 and say, okay, 17 years, there it is. Scroll over until we find a number that's going to be close to 6.8493. 6.8493. The closest one I see here is right about there. That is 12%. I'm going to say the approximate FVIF seems to be 12%. Okay? That, ladies and gentlemen, is our answer. Okay? Hold on, my timer's not working here. All right, so let's prove it. Okay, my proof is going to be, will 8760, all right, grow to $60,000? So I'm going to put years here. We're not dealing with pots of years. I'm dealing with whole years. I'm dealing with interest, and I'm dealing with the running balance, and I believe the number I start with is 8760. Okay, I'm dealing with 17 years, so I've got 1 year, I've got that plus 1, and I replicate that 14 more times. No, more than that. I'm dealing with 17 years. I stand corrected, okay? All right. The amount of interest, I'm going to put 2 decimal places on this because my proof is that this should grow to $60,000. In year 1, if I am earning 12%, that's what I'm trying to prove. I think my answer is 12%. So I'm going to take 8760, multiply it by 0.12, and if I'm right, that is how much I should be making every year, 12%, okay? So at the end of 1 year of compounding, I should have a total of, bear with me, 981120, okay? So I'm going to do that for 16 more years, and let's see how much Madani ends up with. There's my $60,000. The proof is complete. Okay, I hope that helped you. Okay, problem 16. Let's go see what that says. Okay, problem 16 says, okay, Now, this is an interesting one. Okay, a person has just retired and now he's got $200,000. That, today, is the present value, right? Okay, now, he talks to his financial advisor and they think that he's got 16 more years to go until he takes a dirt nap. Okay, his pension fund manager assumes that he can make 12%. Now, he wants to take, out of that 200,000, it's going to be earning 12% every single year. He wants to take money out for the next 16 years, at the end of which this fund will be totally depleted. Friends, that's an annuity. He's got money now. He wants to know how much he can take out, how much he can annuitize year after year after year, so that in 16 years, the balance will be zero. Okay? So for that, I recommend that you use formula number 4. Formula number 4 says, okay, the present value of an annuity is going to be equal to a payment multiplied by the PVIFA. Now, we don't know what the payment is, but we do know the present value of his annuity right now, today, is $200,000. Okay, very good. What's that equal to? All right, now we're trying to solve for the payment. So the PVIFA, we know that it's going to be 16 years, 12%. Go to table D, 12%, 16 years. Okay, we know it's going to be on this line. There's your number, 6.9740. Okay? All right, now we're trying to solve for the payment. So obviously, algebraically, we're going to divide both sides by 6.9740, and that will equal our payment amount. And then we'll prove it, okay? All right, so let's continue and see what that maths out to. We know that our payment, therefore, is going to be equal to 200,000 divided by 6.9740. And by the way, if I cannot make this work out, and if I can't make the numbers dance the right way, I am obviously going to make sure that we correct it before I post this. Okay, so my number, I think, is $28,677.95 per year. That's my annuity. I believe that's how much this gentleman can take out every single year. Now, I'm going to prove it, of course. Okay, by showing you the year, by showing you the amount of interest that whatever is in that account will earn. Then Madani will, I'm sorry, this isn't Madani, this is Alex, will take out a payment, and we're going to have a running balance. Okay, right now he's got how much? Today, he's got $200,000, okay? And he's going to do this for 16 years, so I'm going to keep taking that number, 14 more periods, and that brings me out to about there. There it is, 16 years. Let's see what happens. Okay, so this gentleman, 2 decimal places, there we are. Okay, right now he's got $200,000. Now he's not going to take a payment out until a year from now. Then he's going to take the same payment out every single year. That payment is going to be $28,677.95. So I'm going to take that number and replicate it all the way down. That's how much he wants to take out every single year. Now that $200,000 goes to work for him right away, and it goes to work for him at 12%. So in the first year, he's made himself $24,000. Then he's going to take 28 out. So he starts with 200,000. He earns 24 grand. Then he subtracts minus 28,677.95. He has left, after he takes that payment out, at the end of the first year, 195,322.05. The same formula will work for him every single year, and he should end up with nothing after he takes his last payment out. There it is, okay? That's rounding. I hope you'll concede that point to me, okay? That $200,000 has done its job. Okay, very good. Now, that takes care of the book. The very last thing that I asked you all to try for me was this problem right here. You buy a piece of land for 40 grand. This is going to be similar to problem number 15, except we're not solving for the interest rate, we're solving for the time. So I'm going to copy that, and let's go stick that here. This is going to be problem number, I'm going to call it 17, okay? And let's put that here and solve it. Okay, I'm going to make that a little bit bigger. You buy a piece of land for 40 grand. You intend to sell it. If it reaches 104, you expect that your investment is going to increase 10% every year. You want to know how many years you're going to have to hold that piece of land before you can sell it. This is just like problem 15, except instead of solving for the interest rate, you're given the interest rate and you're solving for the time. Okay? Once again, I'm going to recommend that you use this formula. The future value will be equal to the present value multiplied by the FVIF. Therefore, you can use table number 1. I love to use table number 1 whenever I can. Okay? After all the other tables are based upon it. Okay, let's plug things in. Okay, we know the future value is going to be 104. We know that the present value is 40,000. And we know that we have to solve in 2 stages. The first is to solve for the FVIF. We divide both sides by 40,000 in order to achieve that and find what our FVIF is. Therefore, the FVIF is going to be equal to, okay, 104 divided by 40,000. Okay, the FVIF is going to be 2.6000. Okay, step 2. Now that we've got that number, we go to table number 1. Okay, we know that it's going to be the 10% column. Go to table 1. Go to the 10% column right there and scroll down until you find roughly 2.6. I'll tell you what, it looks an awful lot like that. 2.5937. How many years is that? That is 10 years. Okay, it looks like our answer is 10 years. Okay, I think that's our answer. If this were a quiz and that were multiple choice, you would have your answer. Okay, what I'm going to do is I'm going to prove it to you. Okay, by saying the number of years, we think it's 10 years. Okay, I'm going to put interest. I'm going to put balance, and I want to see, I'll prove this if my number grows from 40,000 to 104,000 approximately. Okay? I think it's going to take about 10 years to achieve that. Okay, so $40,000. I'm just going to take that and add 2 decimal places to it, okay? So now, let's see if this works out. If we increase 10% every year, okay, that's our interest rate. So let's take our running balance, our initial investment, multiply it by 10%, $4,000. That means at the end of 1 year, our investment is no longer worth $40,000, it's worth $44,000. I'm going to take that number and I'm going to take that out 9 more times. I will do so with my running balance, and if I approximate 104,000, we are successful. The number is 103,749.70. Okay, that's close enough. The balance is due to not only rounding, it's also due to the fact that we're approximating 10 years. The answer is not exactly 10 years, okay? I'll make that a little bigger for you so you can see that number. And we are done with our Chapter 2 homework. My next video is going to get into Chapter 3, so please look at these carefully, study them. No surprises on our quizzes. If we cover it here in these videos, it is something you'll see again. And in the meantime, get to me with any questions. Okay? Back to you again soon, and take care. Bye-bye.